To be here, and this day is special for me for another reason. The reason I'm here today is because of these two people here, my uncle and aunt. Without their kindness, I wouldn't be here, so it's definitely a great honor for me to have them here. Thank you. I'm going to talk a little bit about something that I am very passionate about, an area that I've been looking at. But before I do that, I believe in pair programming. So why should I just be here alone for an hour? So I want somebody from the audience who wants to come stand with me here for an hour. Who wants to come here? Please, come on over. He's going to hook you up with a microphone over there. Excellent. And let's talk a little bit about refactoring your language knowledge portfolio. We program. How many of you are programmers here? Excellent. I'm in the right place. How many of you program for a living? You make money out of it? All right. How many of you program to just have fun? Excellent. That's where I am. Right? I wouldn't be doing this if this was not fun. Right? Absolutely, we want to have fun. How you doing?
Yeah, I'm doing good.
What's your name?
My name is Anjan Das.
Anjan Das. Pleasure to meet you.
Yeah, same here.
What do you do?
I'm a software developer.
All right. You code?
So yeah.
Yes. What language do you code in?
So I code in Java
Okay.
mainly, and right now I'm doing something in Android, and we have an application which also on iPhone.
Excellent.
So we also code in Xcode.
And what do you say your name is?
My name is Anjan Das.
Anjan has no clue what he's doing here, right? He's the victim of the day. Just kidding.
It's my pleasure.
Give him a welcome, please. Excellent. So I started programming about, I can't remember now, 25 plus years ago. And I was thinking about it this morning. Why did I start programming? Why in the world did I do that? And I remember the reason I did that is because I was intrigued by the science and the engineering. And you know how back when you are trying to get into the mode, that draws you in. And if that is all there was, God forbid, I would have become a manager a long time ago. But I didn't do that. I decided to stay technical, and I'm coding even today. Coding is my passion. And why do I do that? And the reason is extremely simple, I think. The science in programming drew me in, but it's the art in programming that's kept me in there. And that is one of the things that excites me the most about programming. When you look at coding, it's like writing a poem. There is no one way to write a piece of software. You can write it, you can refactor it, you can evolve it, and then you can keep trying to make it better. And that is one of the most exciting opportunities, is to really evolve the software. What do you think?
Yeah, I mean, I can't agree more. I mean, because when I started, I thought that the programming will be cool. But after that, I found that not only programming, I mean, you have to actually think beyond that. So it's not about if-else statements and switch and then those kind of statements. It's about thinking big and trying to see a real-world problem.
I'm going to stop him here. He's going to finish my talk, I think. No, you hit it on. You couldn't have made it easier. That's exactly where we are going with this. So I think this monitor here is not focused. If you can fix it, that would be great. Thank you. So one of the cool things about this is about a good quote. Actually, this is out of line as well. Do I need to change the font? Pardon me? Oh, there we go. Fix it. So I want to say, this is an interesting quote from Vonnegut. It says, I want to stay as close to the edge as I can without going over. I do quite a bit of mountain hiking. I love mountain hiking. And the thrill of mountain hiking is you kind of get to see over without going overboard. And of course, that's one of the things in programming as well, is to explore the edges so you can kind of explore various things. And of course, we are in a very nascent field, right? Programming is still a very nascent field. We've been programming as an industry for what, about 50 years or so. So let's think about something else in other fields. So I want to buy a car. What would you recommend that I buy?
Ferrari.
I was not quite asking the brand, what kind of car do you think I should buy? What are my options today?
Yeah, I hardly know you, so I would get to know you more so that
Don't
I can
know
recommend
well, think about
car.
the environment. Considering the environment and the gasoline price, what are my options today?
Reva.
I could look for an electric car, or I could go for a gasoline car, a hybrid. Fair enough?
Yeah.
So right there is an electric car, which is not mine yet. But when you go buy electric cars and people get excited, more and more people buy electric cars. I mean, that is the rage today, right? We keep talking about electric cars. Okay. What will happen if a lot of people buy electric cars? We will need stations to charge these cars, right? Rather than having gasoline, we got to have battery stations. So something like this, isn't it?
Yes.
And then what happens? There was a quote, the whole of the United States will be sprinkled with electric chain stations. I think the monitor is still not fixed. Can you help me, please? And so how do you go about, this? Where's this quote from? Surprisingly, this quote is from the year 1899. No, I said it correct. 1899. In fact, the very first few cars manufactured were steam-powered cars. Then the next few cars that were manufactured were electric-powered cars. So this was a very long time ago. And it turned out steam-powered cars actually ran fast, about 120 miles an hour. The only problem is they took a long time to heat up. So you have to be in your home for a few hours before you can start driving. Electric cars were great, but they would run out of batteries, and you get stuck on the roads. And eventually they came up with gasoline cars, and they found that this was more efficient for the time and for a particular reason, and they started manufacturing it really well. And so this has been an interesting cycle to observe. We are getting excited about electric cars, but electric cars have been around for 120 years. Unbelievable, isn't it? In fact, they were there even before the cars we know as of today. So in fact, about 1/3 of the automobiles out there in 1900 were powered by electricity. And what this tells us is this. We started out with steam-powered cars, then electric cars came along, then we went to gasoline power, and eventually now we are back talking about electric cars. And guess what? That's exactly what we are doing in our field today. How's that? We started with structured programming and functional programming back in the 50s. Do you know when OO was introduced? Throw a number at me. Don't worry about being wrong.
Yeah, at least more than 30 years, I think.
More than 30 years ago. How about more than 42 years ago? 1967 is when they introduced object-oriented programming. It took a very long time before it became really popular. And we'll talk about that a little bit later. But eventually, of course, OOP caught on really well. But now, one more time, we are getting excited about functional programming all over again. Why is that? So let's focus here on just Java. This is still out of line. I'm not sure what the problem is. Is there a technician who can help us? So it worked fine yesterday. Should I go all the way to 800? 10, sorry? 768. This one? Okay. Recollect what happened in 1994 timeframe. We had the JVM, of course, and on top of that is the JDK, and top of this is Java. One of the goals of Java was to be simple, if you recollect back in time, right? The beauty of the Java virtual machine is it's very multi-threaded, extremely scalable, one of the most powerful platforms, multi-threaded platform, garbage collection, performance, all those good stuff. Top of that is the JDK, which gives us the power and the versatile APIs, and of course the so-called simple language on the Java virtual machine. Well, actually, it's not true that Java was simple. It's just that Java is simpler than C++. They just didn't tell you that, right? And over the years, we have seen that Java is actually quite complex in a number of ways. But what's happened over the past about 15 years, how things have evolved, is the JVM has become extremely strong. To me, the word Java today does not mean the Java language. When I use the word Java, I mean the Java platform. That's really where the power is. On top of that is the JDK, which is extremely widely used, one of the most ubiquitous platforms out there. And the Java language has turned itself into the weakest link. So there is a pressure to look at other languages, other solutions out there. And about 2000 time frame, I'm going to use the word exodus, but it's an exaggeration, but quite a number of people went on to Ruby on Rails. What these people had to do was this. They looked at this interesting language, which was lightweight, powerful. And what they did is to program in that language, in that environment where nothing existed. They took the bold step and moved away. They had to turn in their passports. They had to sell their homes. And they had to migrate to this foreign land where there was nothing. Guess what? We don't have to do that today. Back in about 2003 time frame, we had a languages renaissance, and we had several languages pop up on the JVM. We got languages like Scala and Groovy and JRuby and Clojure today, of course. And the beauty of this is, if you want to reach out and use any of these languages and their power, you don't have to move a muscle. You could sit exactly where you are and continue to use those features on the Java virtual machine without losing a bit. So what I'm going to talk about here is some of the reasons why we want to do that. So this is where the current state of the language landscape is, with Java, of course, being still a predominant language on the JVM, but Scala, Groovy, JRuby, and Clojure, and about 200 different languages competing in that space. But one of the interesting things about this is, if you look at any of these languages, they're all new languages, but they really aren't new. They all are implementing constructs and paradigms that's been created over 40, 50 years. So what is old is really new again in a lot of ways. But it's really not about the syntax. When people look at a piece of code, they talk and complain so much about the syntax. But that's really a disservice, because syntax is really the least important in a lot of ways, because once you get used to it, you won't even realize you're typing those syntax. So here's the question for you. What's the age of this person? Quick.
80.
80. Anybody agrees with him? 30, I heard. I need to check your glasses. So he says it's 80 years old. He saw this big nose over here, the mouth over here, right? That's the nose and the mouth. Somebody said 30. Who said 30? 20. Hey, this keeps lowering. Quit staring at her, right? Beautiful eyes over here, right? So it depends on what you're seeing. Notice how this is deceiving. Languages are like that too. When you look at it differently, and no two people sitting next to each other are going to see the same thing. You may be seeing the 80-year-old, and the person next to you is seeing the 16-year-old, right? And so it really depends on what we are seeing. Our appearances are deceiving in a number of ways. But what is really important, which he was actually kind of hinting upon earlier, it's really not about the syntactical structure. It is really the idioms that make the most difference. Like, you can learn a language, but it still confuses you. You may speak English, but if you go to London, for example, versus if you go to the United States, they say a phrase, and you don't have a clue what that means, because the words put together, you can look in the dictionary, they collectively don't make any sense. Like, raining cats and dogs. What does that mean? Or slam dunk. And I had to look up slam and dunk, and they didn't really sound really good. But why do they say it's a slam dunk? And so it confuses, because idioms, but where do idioms come from? Idioms come from stories, from cultures, from usage patterns. And if you don't know those idioms, then it becomes hard to communicate. With programming, it's exactly the same thing as well. It's not about learning the syntax of the language, but learning the idioms that make the most difference. So if you want to think about this as an example, why we should know about culture and idioms, I heard about this story about Coke. Coke wanted to sell more Coke in the Middle East. So their marketing department came with a brilliant idea. They said, why don't we create a marketing campaign? We'll show this guy fallen on the ground in the desert. He drinks Coke, and how healthy he is. He runs and jogs, and he's healthy, right? And their sales just went down. And they were like, what happened? What did we do wrong? They forgot to realize these guys read from right to left. So here was a healthy guy. He drinks Coke. Tough luck. So it's extremely important to know a context, right? And so when you code in a language, you cannot say, I've seen people write C code with Pascal. Then they write C++ code and they write in Pascal still. And 20 years later, they're writing Pascal code in other languages. So when you learn a new language, you have to learn a paradigm. That's very important. So let's look at an example. So you're going to help me do some coding here. How about that?
Sure.
So we have a little task on hand that I want to work on. Let me adjust the size here a little bit to deal with the readjust that we did. So I want to take a very simple task. Maybe I have a little prices on my hand, stock prices and stuff like that. So what I would like to do is to write a little code example. So I have a little Java code here to begin with. And what I want to do here with the Java code, is the font size big enough? Can you see it? Yes? Okay, excellent. If you want me to make it bigger, let me know. So I'm going to take some numbers. So list of integer, let's just say for a minute, let's call it integer. And let's call it, okay, can you type integer for me?
Yeah, sure.
So let's say numbers. And what do I want these numbers to be? Let's just say just a bunch of numbers, right? Arrays dot as list. Let's just take a couple of numbers, right? Few numbers. This is enough. So I want to double these values in my code, right? Well, you program in Java, right?
Yeah.
So what should I do first? Create a list of integer, right?
Yeah.
Doubled values equals new array list integer. We create the array list, and then what am I going to do? For a number in numbers, right? I'm going to loop through it. And then within this loop, I would say doubled values dot add number times 2. Sounds familiar? And then we'll output the doubled values. Have you seen that? Yeah, simple, right? And it loops through and doubles the values and prints it out. What do you think of this code?
Great.
Great. How do you feel after writing this code? How about the audience? How do you feel after writing the code? Do you feel good? You feel dirty, isn't it? You go home and you tell your family, don't touch me. I'm going to go shower first before I come home, right? Because if you write code like this, you feel drained at the end of the day. Because there's a name for this. It's called primitive obsession. You had to create an empty collection. You had to loop through this. No wonder people want to become managers quickly. Life shouldn't be this way, right? It's got to be better. And what language are we using here? Java. But I'm going to continue to stay here in Java for a minute. But it doesn't have to be this way. How about this? Just one line of code I'm writing. And what am I doing in this line of code? Numbers.map, given an element E, go ahead and return to me twice that element, please. So this is still Java, right? Java 8. Why not? So you can write code in a much more productive manner. What I'm using here is lambda expressions. And so you don't have to switch languages to do the right things. You just need right things in the right languages. That's it. You cannot do this obviously today with Java 7, but as Java 8 comes up, you should be able to do that. Now, which one would you prefer, the first one or the second one? The second one. If you're writing the first one, how many of you work from home from time to time? A few of us. If you're writing the code in the top, if your child walks in, immediately shut the monitor, right? Because if your children look at that code, they will never take up your profession. Right? They say, Mom, is that what you do for a living? You got to find a better job. I will grow up and protect you, right? Certainly we don't have to do that. It doesn't have to be that way. So look at the beauty of the code below. It is highly expressive. It is highly concise. You get your work done and you go home. How about that? And that is one of the beauty. Another thing that happens here is we are not mutating the variable continuously. There's no mutation in place. That's one of the biggest benefits we see here. So absolutely, we want to be progressing towards those kinds of setup. My good friend Stuart Halloway talks about this you should Google for this and read his blog entry, absolute essential reading material. He talks about essence versus ceremony. Nobody could put that in better terms than Stuart Holloway can. He says good code is the opposite of legacy code. It captures and communicates essence while omitting ceremony. So one of the things we should avoid in our lives, especially when it comes to coding, is ceremony. Why? Because ceremony really slows us down, makes us very counterproductive. Ceremony is where you do stuff you really don't have to do. But why are you doing it? Not because you want to, because the environment forces you to do that. That is ceremonial, right? Let's look at an example. Here is a wonderful dolly. Who's Dolly, right? The sheep, the first sheep to be cloned. So let's talk about cloning for a minute. So I'm going to clone an object. How would I clone this object? So let's just start with, I'll just go ahead and say output OK here, so we can see the code is working right now at the moment. I want to start writing a clone method. So public object clone. What do I want to do in the clone method? I just want to return the cloned object. So return super.clone, right? I'm done. What does Java compiler say? It's, well, okay, I can implement clone, but I don't even have to get that far, right? What does it say? You have to support clone not supported exception. Excuse me, I am supporting clone. And the Java compiler says, but you have to throw clone not supported. You argue. You should never argue with the Java compiler, by the way. That's a bad thing to do, right? And you tell the Java compiler, but I am implementing clone. And Java says, but you will have to throw this exception. And finally, what do you say? You just give in, right? He's like, fine, let me put that in, are you pleased now? So you just throw that word, and you shake your head, and you say, this makes absolutely no sense, but if that's what you want. So clone not supported, exception. And what does Java say? Java says, you're good. How do you feel about it? Another shower, right? Feel dirty. This is an example of ceremony. Have you ever had a need to call thread.sleep? Yes? Yeah. What do you do when you call thread.sleep? You put a try and catch around it. I've been sleepless in the night, wondering what I would do with this exception I don't care about. That is an example of a ceremony. Have you ever had a reason to teach Java to anybody? Have you done that? Yes? Sorry. You said, I will teach you Java. And what does the person say? Is it easy? You said, it's simple. Because all the books told you that. It's got to be simple. And the person says, why don't we learn something really simple? How about a hello world? Sounds fair? All right, we'll teach this guy to write hello world. So how do you write hello world? All right, ready folks? It's a class. We're going to teach hello world. Let's do that. So public, excuse me, teacher, yes. What's public? You don't need to know that right now. Student takes notes. All right, go on. Class. Excuse me, teacher. What's class? You don't need to know that right now. Hello world. Such a relief in the student's eyes. Yes, we finally got there. And then you put the curly bracket. Comes crashing down. What more? Aren't we done? No, we got some more. We're not done yet. Then you say public. The student immediately looks at the notes. They don't have to know this. Then you said static, and that's it. You blew them over the wall, right? What is the static stuff now? Is it something I don't have to know also? You lost the faith of the student completely, right? What is this called? Ceremony. You're doing stuff that keeps you away from doing things. That is ceremony, right? You want to print hello world? Why don't you just go and print hello world? Let's try that. Here is a code in Scala. Print line, hello world. And Scala says, thanks for using me. And it doesn't complain to you, right? Almost. Parentheses, we'll fix it in a minute. Right? You didn't have to write classes. You say, wait a second. This runs in the JVM, and the JVM requires to have a class with a main in it. Of course, all this is true. But that's the language's problem, not your problem. Why should that become a tax on you, right? Exact same thing in the case of Groovy, for instance. I could go to Groovy and say, print line, hello world, and Groovy says, thanks for calling. You don't have to be doing ceremonial stuff. And I won't even talk about what it takes to read a file. How many lines of code do you need to read a file in Java? He is still counting. How many? 24. I like that accuracy. 24 lines of code in Java. Let's try this here. I'm here in Groovy, and let's ask Groovy, could you please do this for me? New file, I'm going to read etc. host. Dot text, print line this file's content. Done. You can go eat the lunch of the guys who are still opening their IDE in Java. Right? Why waste time and effort? We got real work to do. And you want to eliminate that ceremony, and that's exactly what Stewart is talking about, is figure out where there is ceremony and remove it. This is something I didn't realize quite a bit, by the way. Statements versus expressions. When a language has statements, it's damned. Because what is a statement? A statement says, you call me, I will do some operation, but I will never respond back to you. I won't give you back anything. That's what a statement means, right? We say the word if statement. You call if, what does it say? I'm done. And what did you find out? I won't tell you. Well, how do you know what if did? You got to set a variable's value. You put a flag in there. How does it feel when you have to put flags? Another showering. That's right. When a language only has expressions, you get two benefits out of it. When a language only has expressions, there's no statements at all in the language. Like Ruby and JRuby, Groovy for now, and Scala to a great extent. Clojure, certainly. You can compose these expressions very easily. And expressions don't require mutability because they can yield results back to you. Statements insist on mutable variables. So it's a fundamental flaw in the structure, idiomatic fault. It's not a syntactical concern, right? But we have to be careful, though. I don't want to give you an impression that I hate Java. Actually, I love Java. In fact, I will secretly admit something to you if you promise not to tell anybody outside this room. I got secret crush on C++ as well. And I've done this for years. That's where I grew up. And each language has a mark it leaves. Think back in time. You probably recognize this gentleman here. His name is Bjorn Stroustrup. He's the guy who wrote C++. He was a PhD student back then. He was programming in a language which was kind of like Snowball, and the program was so easy to write. And he ran it, and it ran, and it ran, and it ran. And he got worried he may never graduate because the program is still running. So he kind of abandoned it, took something like C and wrote it. And man, it ran blazingly fast. But it failed in so many places. It had errors all over. And he kind of patched it up and graduated from school. Went to A&T Bell Labs and they said, sit in this corner and do something about it. He kind of thought about this. This was kind of wild, right? I had this beautiful language, but it ran slowly. Here's a language that's really hard to work with. Would it be nice to create a fast and furious language that provided object-oriented modeling? How do you describe C++? The way I can describe C++ is like this. It's amazingly fast, but incredibly dangerous. In fact, Bjorn Stroustrup himself describes C++ in the best way. Here's how he describes C++. Couldn't be better, right? That's his words, by the way. So he says it's a language that will help you to shoot yourself in the foot. You can recognize C++ programmers. No, not by looking at the foot. They are so excited to go to work because they have no clue what this code is going to do today, right? It's extremely fast and dangerous and furious. And this is politics of programming languages, by the way. What do you see in the politics? 4 years goes by and one guy says, the current government sucks. Elect me, I will solve all your problems, right? 4 years later, somebody else comes and says the same thing. And we're kind of silly, we keep electing these people. That's exactly what happens in programming. Java came along and said, C++ is furious and fast, but it's complex. I will solve all your problems. Program in C++. And what did Java syntax look like? C++. The other day, by the way, I was coding away at my home quietly. My wonderful wife comes over, leans over, looks at my code and says, Venkat, you have to be ashamed, and walks away. I said, Patricia, I refuse to take that. Explain to me why I should be ashamed of myself. And she said, you talk all these stuff, and years later, I catch you coding C++. I said, no, definitely not. This is Java. In fact, look at the extension. It says .java. And by the way, she's not a programmer. This is what is the scary part. She comes over one more time. This is where you should know to shut up, right? But I'm still learning in my married life. She comes, looks over the code and says, fine, I'll give it to you. It doesn't have delete, but it's Java. It's C++ otherwise. I mean, that's the similarity the language has to C++, right? No deletes, but otherwise very close to it. But is Java valuable? What did C++ do, by the way? C++ took the paradigm of object-oriented programming and made it mainstream. Let's not forget that. That is the reason I love C++ for the change it made. Now, going on Java, what did it do? It brought the virtual environment into a reality. We didn't have that before. Garbage collection, managed code, right? That is wonderful contribution. That is the power of Java, and we should not forget that either. Which comes to the point I want to make. I started seeing these languages very differently, and that is why I don't hate languages. I embrace all of them. I look at languages as bridge languages. And what I mean by that is, these languages help move a mass of people from one paradigm to another. That is exactly what C++ did. C++ was the bridge that took the C programmers of the time and said, you don't have to do things too differently. Just walk over this bridge and you can be in this object-oriented land. You could get very technical about it and argue endlessly whether C++ was over or not. But it doesn't matter. The world has moved on. And that is exactly what Java has done. It took all these people and said, you could run your code in a managed environment in a way that you can write code once and debug everywhere. Right? So they give you these kinds of capabilities, and that is why I look at languages as these bridge languages. But there are some new bridges out there. Scala, JRuby, Groovy, Clojure, and all these wonderful languages. I showed you a little bit of Scala code, a little bit of Groovy code, not much. But what can you do with these languages? I'm not going to spend time here on JRuby for lack of time, but I'm going to show you a couple of things you can do with Scala. Do you like XML, my friend?
Yeah.
Okay, he's one of those few people who likes XML. So I'm going to create greet equals, let's call it greet, hello, greet. And right there, we created an XML, right? And let's print the XML we created. Fair enough? Did we create XML? No. What did we create? A string. How would you feel if I put you in a string? Angry, violent, right? Now you know why XML behaves like that. Because in every language, you put it in a string. And no wonder it's angry at you. So I have this theory about XML. XML is like human. They are cute when they are small, but they're really annoying when they become older, bigger. XML is really annoying, right? When it's big size. And now you're like, how do I deal with the size of the code in XML, right? But Scala says, you know what? XML is not that bad. It deserves a little bit of respect. I mean, it's a good thing, right? Respect is good. So notice what I'm doing here. I'm removing the shackles. And Scala says, why not? I know this is a bit scary when you look at it, right? But in Scala, XML is a first-class citizen. You can drop a well-formed XML anywhere in the code, like you would drop integers and doubles. I'm just merely scratching the surface. I have a talk later on today, which is just exclusively on Scala. I'll praise its power a lot over there. One of the strengths of Groovy is the ability to do meta programming. We can do a couple of interesting things here. Let's say I have a class called employee. Let's look at the power of this. And I'm having a method here called work. And what does the work method do? I'm going to simply say working, right? And it doesn't do anything, just says working. That's good enough. And Then I have a class called manager. As you would clearly expect, the manager does nothing. This manager is smart though. We all have read books, right? And what do the books say? It's better to use composition or delegation instead of inheritance. Remember that? We all read that book, put it down, and we started writing inheritance. Why? Because that's a great idea. Thank you, for author for letting me know that. But I'm programming here in Java. It doesn't give me a better way to do this. Inheritance is so simple and easy to do. It makes life harder otherwise, right? So notice what I'm going to do here. I'm going to come down to this manager, Bob equals new manager, and I'm going to say Bob.work. I know how hard it is for Bob to do that, right? He says method missing. But Bob is clever, like I said. So I'm going to say here, employee victim equals new employee. Actually, I should have called it slave, but that's another day. Delegate, and we just delegate the responsibility. And notice how trivial it is to start routing methods. Of course, again, I'm merely scratching the surface here. There's a lot more you can do with it. So this is the power of languages. It removes ceremony, and you can do really, really wonderful things with it. But what does this really mean? These languages share something really common. One of them is conciseness. They're very highly expressive, but they also support functional style of programming. Hey, wait a minute, I keep mentioning functional style. What in the world does it mean? One of the things that functional style of programming talks about is immutability. Something that doesn't change. Do you know anything that doesn't change?
Change.
The change.
Change doesn't change.
Well, change changes all the time. That's what Heraclitus said. The only constant is change. Anything else? Your boss, maybe? No?
No.
Okay.
I switch
what was it?
Yeah.
Taxes. Taxes, you said. It's April time in the US. I feel your pain. Yeah. Actually, it changes. It increases every year. It gets worse. All right. Something doesn't change. What's the benefit of it? What about mutability? Yeah, you know what? Mutability is not too bad, really. What about sharing? Is sharing a good thing? Absolutely. Remember what mom told us, right? Share, kid, share. So mutability is all right. Sharing is okay. What about shared mutability? That's devil's work. The minute you start sharing mutable variables, you got to protect all kinds of threads coming in, and it becomes messy to deal with it. The program becomes complex, very hard to maintain. Most of the concurrent applications in Java today are broken. We don't even know that. That's kind of scary, isn't it? When a variable is immutable, what happens? It doesn't change. When something doesn't change, how many locks do you have to put on it? Nothing. No locks. What a beautiful thing to do. Lock-free programming, right? So it really makes it easier to write code with it. And it also provides functions which are pure, no side effect. What does that mean? Look at the function as a black box. You call the function. Whatever input you send, it doesn't change it. The function doesn't modify anything outside. Anything outside doesn't modify what's inside the function, and it produces an output. What's beautiful about this? As long as you keep sending the same input, you get exactly the same output. It becomes easier to test it. It becomes predictable. But there is more advantage to this. If I have two expressions which are independent of each other, I got one expression on this hand, another expression on this hand. If I'm the compiler, I look at these two code and say, I'm going to run expression 1 first, and then I'm going to run expression 2. Fair enough? But I say, you know what? I'm going to flip them. I'm going to run expression 2 first, then I'm going to run expression 1. Why not? They're independent, and they have no side effect, right? But such a compiler can immediately also say, hey, I just realized I've got a multi-core processor on hand. I'm going to run them concurrently. I love that, the music, when nice things are being said, awesome. So right there, you can run them concurrently without fear of loss, fear of accuracy loss, right? That's the beauty of functional style. It's inherently thread safe, easier to use on multi-core processors. Now you know why functional programming that was created 50 years ago, like those electric cars, are all again the rage of the time. And the reason is we have multi-core processors. I don't want to reveal my age to you, but there was one day I went to the streets and I celebrated on the streets. My neighbor said, "You're shouting on the street. What's up with you?" I said, "My computer has 10 meg hard drive." That was the happiest day of my life. Can you imagine? I have 10 megs of hard drive on my computer. That was a great day. Now, my iPhone has more memory, more space, more power, multi-core. This is powerful, more powerful than some of the machines that I had in the past. And this is the only trend we are in. So it's important for us to be able to utilize these multi-core processors. But what's keeping us back? It's all of us. Because the hardware power is on hand, but we don't have the expressive power to program the machine reliably. What a shame, isn't it? This is like having a great food in front of us, but having an indigestion. I cannot have that food. No, sorry, thank you. Right? And you want to be able to utilize this hardware. That is the beauty. And it provides higher order functions. So how does this work? When you have an object, it contains a mutable state, and the object maintains state. So you call a function, and you change the state. But you do this a little differently. This is mutability on hand. Do you have $10 with you?
Oh, my wallet is there.
I know how that is. Okay, fine. I'm glad I brought it. So I need some change. I'm going to ask for help. Actually, Dilip, can you help me? I got a 10 rupees. I need to split this. So I'm going to ask him for his help. Because he's a nice gentleman, he can help me. And I'm not going to ask you, you don't have your wallet. I was going to ask you. So I want you to split this into 2 for me, please.
You sure you want me to?
Yes. Oh my God. Well, thanks for your help, Dilip. You said you'll give me the $10, right? That makes no sense, but thanks for your help. You see what's going on here, right? That's not the way you will give change to somebody, right? Do you have friends, Dilip? They're still friends with you. There's a reason she's sitting 3 rows behind. That's not the way we make change. How would we make change? Let's try this again. They have 100 rupees with you. We're not going to do that. I take my 10 rupees and I give it to my good friend. I should have called Arun here. What was I thinking? Arun, I'm going to give you $10 to you. But Arun only has 2 5s, but I want 1s. What's he going to do? Arun is going to take my $10, but he's going to take his 2 5s, being a nice gentleman he is, sends it to Josh, and Josh has 10 1 rupees, and he's going to give it to me. Now notice what happened. I give him $10, Arun sends the 2 5s to Josh, and Josh gives me the 10 rupees. Am I making sense? What did we just do? We started out here with these functions on hand. So this is me, that's Arun, and that is Josh. But we are all pure. Well, okay, at least Arun and I are pure. We don't know about Josh. Just kidding. We are pure. What does it mean, pure? We don't mess with stuff. We don't change things, right? We don't mess with data. So you send the data to this function first. It doesn't mess with it. It sends another set of data to the next function. That doesn't mess with it. It sends another set of data to the next function. And then that gets forwarded back, and you get a result. That is how you structure a functional program. So in other words, we get so hung up on mutability, and we kind of miss the point in a way. It's not about state mutation or avoiding it. It's about state transformation. You want to transform the state, and that's what you're doing in a functional style of programming. Let me quickly give you an example. Don't read this code. I want you to just kind of highlight some of the features in this code. So don't worry about the syntax and all this good stuff. You could do this in Java 8 also eventually if you want to. So what I have here is tickets. Tickers are symbols of stock prices. That's what I have on hand. You can download this code elsewhere later on and take a look at it. So this one here is all the ticker symbols I'm interested in, a number of ticker symbols. I'm going to lower the font here a little bit so we can see it. So I got these ticker symbols, and I've got a little class that's going to hold the details for us. I got to get price that's going to go to Yahoo and get the price of the stock. And I have a pick higher price to stock. This function, by the way, takes two stock prices and returns to me the price which is the highest. Fair enough? Nothing really big deal, right? Don't read the code, just look at the function names and what they do. Is not over 500 tells me whether a given stock is over 500 or not. So I've kind of set up the things I need. Now notice what I'm doing. This is the imperative style of coding, like the way you do in Java, right? I loop through all these stickers, and I get the price for each of these, and I put it into the array. That sounds familiar, isn't it? And you know what you will do after writing that code? Shower, right? So that's a familiar code, right? Then what do I do? Another loop. How does it make you feel? Another loop. One more loop. What am I doing? I get all the prices, then I go over and find all of them that are less than $500. Then I pick from them the prices that's the maximum, right? So 3 operations I perform, right? Given all the ticker symbols, I got all the prices, that's the first function. Then I say thank you. Then I say, here is all the prices. I'm going to start filtering those that are not over 500, second operation. Then the third operation is, here's the one that's the maximum among those, right? But notice I wrote 3 loops. And what did I use as a construct? A for statement. Remember what I mentioned about statements earlier, right? They don't give you results back. They just do the operations. They promote mutability in code. We're going to do this one more time, but in a more of a functional style, by the way. How is this going to look like? So right there, the very last line is the only line I'm writing. Tickers map, get price. Once you have all the prices, compose that into filter is not over 500. Pass that to a reduce method that picks the highest price value. Finally print it. This is following exactly the same sequence that I tried to get the change from Arun and Josh, right? You pass along in a sequence of steps and you get the result with no mutability in between. You can run that code and play with it if you're interested and see how easy it is to write code like that once you get used to it. So that is one of the best things about this. So given all of this, let's conclude with a few things. You say, this is all great, I want to do it. How do I go from where I am? We are looking at game changers here. None of this matters, by the way. None of this matters if you don't make use of it. That's the whole point, right? You have to be able to make use of it. So I'm going to talk about 2 things. What can you do as a company, as a team? What can you do as an individual, as a single person? A corporate strategy to think about. Evaluate risk versus reward. There is risk, no doubt about it. But there is a huge amount of reward to go and use these things. I got a client of mine. They evaluated this and they realized this will shave away their development time by a few years of development. It was a calculated risk for them. Then they engaged in an activity where they did prototyping, took time to learn about it, and they asked a lot of critical questions, not by just verbally, but by writing prototypes. And once they cleared those concerns they had, it was clear to them that they should go in this path. And that is extremely important. Think about this for a minute. Imagine the year is 1920. Imagine you're only 19 years old. And imagine airplanes have not been flying for a long time. They've been flying only for 8, 9 years. Unproven technology, right? And on the left here is Salt Lake City. On the right here is Cheyenne. As the crow flies, it's about 370 miles between the two places, 440 miles. And in between is the Rocky Mountains. Extremely hard in the winter to go through. And winter is most of the year, sometimes up in the hill, 14,000 feet, up the ground. And imagine you are, working for the Postal Service. And you got to go drop mails into Cheyenne. How hard it is. But there was this 19-year-old kid who got his first license from Wright Brothers. His name was Jepson. This kid said, you know what? I'm going to brave my way. I'm going to fly airplanes for you. And he starts flying airplanes, but there was one problem. Nobody has flown airplanes in that region. And back in time, they did not have maps. There was no maps for airplanes. Imagine that. And what these guys would do is they would get on an airplane and they would follow the railway track. That was their map, seriously. Union Pacific Railway track. So airplanes would fly low because they need to know if they're in the right direction. And sometimes they would deviate and people would die because they would crash. They wouldn't know where they're going. Not only did he start flying, he started taking notes. He started taking notes. Oh, here's a little peak like this. Here's this form like this in this shape. And he started creating a map. This guy was the first guy who created aviation maps. Look at that. That is opportunity to define a field. And airline companies bought his map. He really became the first guy. He started selling his map to other pilots for $10 a piece. And when eventually United Airlines bought this company, they abandoned their own set of things and started using his. Denver Airport is actually named after him. But we cannot succeed without failures. So what do? We could shy away, hide somewhere, and wait for the world to succeed and move on. I was talking about electric cars and car manufacturing. Back in time, there were 150 car manufacturers. About 3 or 4 of them survived. There is no way to eliminate that. So what do? Create failures within your company. And some of them will succeed, and guess who wins? Your company does. And this is actually something we can learn from the bees. What the bees do is they wake up in the morning and they want to go get food, and the bees go out, disperse, and they go in small groups. And bees will go look for food. And when bees find food, they come back to the hives and they do what's called a waggle dance. And they dance, and the more honey they found, the more happier they are, and you will know which bee found more food. And the rest of this bees will follow that. The other bees which failed would follow them too. So it depends on which bee is going to win that day and which will not. We could do that. We could go out and put people to explore these technologies, and then they come back and say, here's what we found, here's what works, it doesn't work. And you will figure out what works for your company, and you can make use of it. So set up these opportunities to fail and make them your stepping stones quickly so you can win and make use of it. What can you do as an individual? Who cares the most about you at work? Your manager. This guy is in serious trouble. Abhishek, you and I need to talk. Abhijit, you need to talk. We need to have a long conversation. And don't answer when I ask this question now. Who do you think cares about you the most at work? Yourself, that's correct. Absolutely. We are like this candle, by the way, right? You're put there, you're burning. And what does the candle do after a while? Burns up. Does your company say, that was a great candle? We're going to live in darkness forever now on. Before it's even completed, they bring in the other candle, right? That's exactly what's going to happen. You need to be competitive. It's your career, your life. The more you know, the deeper you know, the better you are. So you need to invest in yourself. Alan Torfel has a beautiful quote here. He says, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. Relearning, unlearning is so important. We got to do away with the old way, the old paradigms of doing things, and pick up the new ways of doing it is extremely important. We cannot forget to do that. So how do we go about doing this? This gentleman here, Ivan Pavlov, was a Nobel Prize winner back in the 1900s, and he did something interesting. He studied the digestive system of dogs and other animals. He was a physiologist. He was not he was not in psychology. But those people who go to psychology school read his work. How is that possible? As he was studying these dogs, he noticed something interesting. The people working in his labs, some of them will walk into the room and the dogs will salivate right away. He thought that was weird. One of the lab assistant walks in and the dog salivates. Somebody else walks in, it doesn't bother. So he was like, this is kind of strange. Why does it salivate with some people, not others? So he started studying this a little deeper and found out those people who it salivated for are the people who were feeding these dogs. They were not walking in with the food, by the way. They were walking in to do their work. But the minute they see the people, it would salivate. Then he realized, in the beginning, salivation was involuntary because the food makes us do that. Like probably you're doing it right now when I say the word food, right? However, as time goes on, it's the environment that causes it. The point of his research, we're not dogs, absolutely, we're intelligent human beings, but we have lovely dogs as friends. But what his research tells us is the environment shapes behavior. If you want to learn, and if you want to get really good at what we do, we have to create an environment that fosters that. I will tell you what you shouldn't do. If you do this, don't. That's not the way you want to code, right? You want to mingle with people. Get along with smart people. And code, practice, critique each other. Challenge others, challenge yourself and say, hey, what are you learning today? Have you tried this? Have you tried Scala? Have you tried Groovy? What are your reactions to it? And engage in such an intellectual conversation, then we elevate ourselves. As John F. Kennedy said, there are risks and costs to a program of action, but they are far less than the long-range risk